Welcome to another new video on Introduction to Quality Assurance and Test Management. So in this video, we're gonna talk about software quality attributes, types of QA, test phase and test case, and then testing levels of V model. This video could be a bit longer. However, the following concepts are crucial for understanding our next chapters. A strong foundation is essential for easier learning later. To reinforce these concepts, I have included a detailed outline of the video content in the description. Feel free to review these topics as often as needed to solidify your understanding. So let's dive in. Software quality attributes are categorized into two primary groups like functional quality attributes and non-functional quality attributes. Functional quality attributes work on these following leads: accuracy, compliance, stability, security, and interoperability. On the other hand, non-functional quality attributes work on functionality, reliability, usability, efficiency, maintainability, and portability. For example, when developing a new e-commerce platform, we must carefully consider both functional and non-functional quality attributes. Functional quality attributes like accuracy, security, and interoperability are essential to ensure the platform can process orders correctly, protect customers' data, and integrate with payment gateways. However, non-functional quality attributes such as reliability, usability, and efficiency are equally important. A reliable platform must be able to handle high traffic loads without crashing. A user-friendly interface must make it easy for customers to navigate and make purchases. And efficient performance is crucial for a positive user experience. Types of QA. Constructive activities to prevent defects through appropriate method of software engineering, and analytical activities to finding defects, leading to correcting defects and preventing failures. Here you can see the motto of constructive quality assurance. Defects not made need not to be fixed. Defects that were made won't be repeated. Prevent defects. The guiding principle for our development team. We strive to prevent defects by implementing rigorous code reviews, unit testing, and continuous integration. When a defect is discovered, we conduct a root cause analysis to understand the underlying issue and implement corrective actions to prevent recurrence. By focusing on preventative measures and learning from our mistakes, we aim to deliver high-quality software that meets customer expectations. So, constructive QA can be categorized into organizational and technical part. You can pause this video and go through these organizational and technical elements here. So, analytical quality assurance ensures quality of product through verification and test procedure. And it also ensures that the defects should be detected as early as possible in the process. We can categorize analytical quality assurance into two primary components: dynamic and static. While we'll dive into dynamic methods including white box, experience-based techniques, and black box later, let's focus on the static methods for now. Static methods involve reviews and workthroughs, examining the code manually to identify potential issues. Control flow analysis, analyzing the flow of control within the code to detect logical errors or inefficiencies. Data flow analysis, tracking the flow of data through the code to identify potential problems like dead code or unused variables. Computer metrics, using automated tools to measure code complexity, maintainability, and other metrics. What is test case? A test case is a detailed set of instructions used in software testing to verify a specific functionality. For example, a test case for a login feature might include the input values, preconditions, expected results, and post conditions. By following test cases, quality assurance engineers can systematically test different aspects of software to ensure it meets the required quality standards. So, in a test case template, we can start with a unique identifier. Then conditions like preconditions, post conditions, which is expected, and values like a set input values and expected results. Relations and some optionals like how to execute test and how to check results and the priority. Now we will discuss about the testing levels of the V model. So here you can see the levels: acceptance test, system test, integration test, and component test. We will start from the bottom so that we can have a step-by-step understanding here. So at first, component test. Component test is a test of each software component after its realization because of the naming of components in different programming languages. The component test may be referred as module test in C programming, class test in Java and C++, and unit test in Pascal. Component test is called developer's test. Here in this component test, only single components are tested, where components may consist of several smaller units, and test objects often cannot be tested standalone. Again, every component can be tested on its own, where finding failures caused by internal defects. Cross effects between components are not within the scope of the test. Component test cases may be derived from component specifications, software design, and data model. In component testing, stubs and drivers are essential tools for isolating and testing individual components. A stub is a simplified version of a dependent component that provides predefined responses to calls, while a driver is a program that calls and controls the component under test. For example, to test a module that processes customer payments, you could use a stub to simulate the behavior of a payment gateway and a driver to send payment requests to the module. And finally, here we can see the methods of component testing. The program code is available to the tester. In case tester is developer, testing takes place with a strong development focus. Knowledge about functionality, component structure, and variables may be applied to design test case. Often functional testing will be applied additionally, the use of debuggers and other development tools. In unit test frameworks, it will allow to directly access program variables. Source code knowledge allows to use white box methods for component test. Now we'll have a discussion on integration testing. We can refer integration testing as interface testing, and this integration is the activity of combining individual software components into a larger subsystem. Examine the interaction of software elements after integration. Further integration of subsystems is also part of the system integration process. Each component has already been tested for its internal functionality. Integration tests examine the external functions. Integration tests examine the interaction of software components with each other, like interface with the other components, interfaces among GUIs and MMIs. Integration tests also examine the interfaces with the system environment. In most cases, it is of the component and simulated environment behavior. Under real conditions, additional environment factors may influence the component's behavior, and a test case may be derived from interface specifications, architectural design, or data models. System test. In system test, test cases may be derived from functional specifications, use cases, business processes, and risk assessments. It refers to functional and non-functional requirements, here testing the integrated software system to prove compliance with the specified requirements. These are the functional requirements of system test: business process-based test, use case-based test, and requirements-based test. In business process-based test, each business process as basis for driving test cases. The ranking order of the business process can be applied for prioritizing test cases. Test cases are derived from sequences of expected or reasonable use in use case-based test. And in requirements-based test, test cases are derived from the requirement specification. The number of the cases will vary accounting to the type or depth of specification requirements-based test. The non-functional requirements are here. These are really difficult to achieve. Here, each business process as basis for driving test cases. The ranking order of the business process can be applied for prioritizing test cases, and quantifying them is difficult. Often, non-objective metrics must be used. So this video is already so long. We will continue acceptance testing in our next video.